1.1 is real numbers and number operations. The first thing we need to know about real numbers is that they have different classifications. The first type of numbers that we're going to talk about are going to be the natural numbers, and we're going to make a little diagram, so you're going to want to leave some space in here. The first one that we talked about is natural numbers. The natural numbers in math, we like to use a double-barred N. So it's an N and it just has these two bars. That's the shorthand symbol for natural numbers. Natural numbers are the counting numbers. 1, 2, 3, and so on. These natural numbers are part of more classifications. The next one that it's part of is called the whole numbers. The whole numbers are the counting numbers as well, because the naturals are part of them. But it's also and 0. So 0, 1, 2, 3, and so on. So the natural numbers are inside of the whole numbers. One way to help distinguish between the two of them is that whole has an O in it and 0, so they go together, whereas natural does not. Therefore, there's no 0 that is in it. Okay? Now the natural numbers and whole numbers are part of the integers. Oops, let's go back one second. The whole numbers, for shorthand, we're going to use a double-barred W. So there's the double bar, and then W. That's the shorthand, instead of having to write out the word whole every time. Integers has its symbol. It's a double-barred Z. So there's the top of the Z. There's the one bar of the Z. There's the second bar of the Z. And the bottom. Now integers, they are the natural numbers. They are the whole numbers. But they're also the negatives. So they are the opposites that we have to what's going on with the natural and the whole numbers, the positives and the negatives. And all of those are encompassed in the integers. All right? Natural numbers, whole numbers, integers are all part of what we call the rationals. The rational numbers, we don't have a symbol for it, so we just generally abbreviate them as R, A, and T. The rational number is any number that can be written as a fraction. Of an integer over an integer. So some integer divided by another integer. Now those are z's, even though they kind of look like 2's. And 2 would be an example of 2 over 2. Negative 5 over 1. 0 over 3. That does not matter too much. But the rational numbers is any number that can be written as a fraction. So this fraction word is quite important. We need to make sure that we understand a rational number is really just a fractional number. Now, sometimes our fractional numbers are written as decimals. So not only can it be written as a fraction, but it can also be written as a decimal that ends or repeats. All of those are going to be considered rational numbers as well. So 0.5 is a rational number. 0.333 repeating is a rational number, because we should know that 0.333 repeating is actually 1/3, and that is a fraction. So any decimal that repeats or ends, or anything that can be written as a fraction, is called a rational number. Naturals, wholes, integers are all part of rational numbers. Now, there is a second component to separated from rational numbers, and those are called the irrational numbers. Now, for irrational numbers, we like the this double-barred Q. That's the symbol for the irrational. Irrational is its own number set. If you are rational, you are not irrational. And vice versa. If you're irrational, you are not rational. So we have two different sets here. An irrational number is only a decimal value with no end and no repeat. Because if it ended, it would be rational. If it repeated, it would be rational. So it's going to be a decimal value that does not end and does not repeat. The most common of these is pi. If you plug that in your calculator, you get 3.14, blah, 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 keeps going on forever, never ends, never repeats. Radical 2 is another example of an irrational number. And then you could just have something, 2.413710988, ... and it keeps going on forever and ever. It doesn't end, it doesn't repeat. That makes it an irrational number. When you are rational or irrational, you are said to be real. So all of these are real. And for real, we like to use the double-barred R. Real numbers is everything that can exist. And you're thinking, well, of course it exists. It's numbers. But you're going to see later on in some later chapters that we're going to have things that are not real. So for right now, everything we have is real. It either falls into two major categories of irrational or rational. And then if it's rational, it does have subcategories that it could also belong to. So you want to be able to classify numbers based on the classification that it falls under. So if you had the number 2, you would say, first of all, it's real, because everything is real. You would then say it's rational, it's an integer, it's a whole number, and it's a natural number. If you have the negative square root of 5, well, it's real. Everything is real. And it's irrational. Square root of 5, if you were to check the decimal representation of it, it does not end and it does not repeat. If you have 1/8, 1/8 is real and rational. So it can be some, it can be all, but it definitely has classifications, and you need to be able to list them all or categorize them into whichever one that it belongs to. So that's the first part of 1.1, real numbers. Now we need to look at their operations. So their operations, a lot of it is just some vocabulary and getting used to some certain properties that go with it. The first thing we want to know is that all of our real numbers, they go on a real number line. And that may sound obvious, but when we make real number lines, we don't always make them in the correct format. On a real number line, and this is going to hold true every single time you make a graph, is you're going to make a number line that has arrows, because a number line does not end just because we run out of paper. We're always going to label that number line. It's going to be an X, it's going to be Y's, it's going to be Z's. It doesn't matter. You could just put that it's N's for numbers. But it always has to have some kind of a label. It always has an origin, and then it's going to have whatever point that you have. So first of all, we have arrows, we have labels, we have an origin, and then we're going to have the point of wherever it is that we're talking about, whether it's 1/2, whether it's -7, whatever that we want with it, knowing that negatives are to the left of 0 and positives are to the right. Graph. Graph is actually a noun. It is the point on the number line that corresponds. Graphing is the actual plotting of that point. Coordinate is the number that is that point. Inequality symbols are what we're going to use. Less than, less equal, greater than equal, to show order of points. So you will be asked to plot points. You will be asked to label those points. You will be asked to put them in order, where they at smallest to largest, largest to smallest, in relationship to the origin. So 1/3 is going to be closer to 0 over here than -3. So you're going to put them in a corresponding relationship to the origin. All right, the next piece of information we have are called the properties. When it comes to properties of our number lines, or of our real numbers, the properties only relate to add and multiply. The first one is called the closure property. The closure property says any two things added together is the same value. Same thing with multiply. Any two things multiplied will always give you the same value. 1 and 2 is 3. 1 plus 2 is 3, always and forever. There's no absolutely any other way that you can do it. 1 times 2 is 2. always going to be 2 no matter what. There's nothing else you can do about it. Next one is commutative. Now, commutative allows you to flip your information. What this says is I can add in any order. 3 plus 4 is the same as 4 plus 3. And multiply the same way. Next property is the associative property. The associative property allows you to group numbers together in any order. So if I have 3 of them, A plus B plus C, well, let's say if I do A and B together, that's the same as if I wanted to do B and C together first. It doesn't matter the order, I can group them in any way. And the same holds true for multiplication. I can group them any way that I want as long as I am adding and multiplying. Next one is the identity property. The identity is what is going to give you yourself back. So in order to get myself back, what do I add? 0. That's how you get yourself. When I'm multiplying, I multiply by 1. That's how you get your identity. The identity is to add by 0 or multiply by 1. Now the inverse is to do kind of the opposite of your self. Inverses means how am I going to get 0 and how am I going to get the 1. They're kind of opposites of each other. So how do I get 0 if I start with A? Well, I add its negative or add its opposite. When I'm multiplying, I have to multiply by its reciprocal. The reciprocal is to flip the term that you have, and that allows that to cancel, leaving just the 1. All right, the next property we have is called the distributive property. Should be familiar with it. The distributive property just says that we can multiply whatever's on the outside to whatever's on the inside. So we're going to take A times B and A times C. Now, if you had a plus sign in here, it's going to be the plus, and if I had the minus, it would be the minus. But the distributive just says whatever's on the outside is going to get multiplied to everything that's on the inside. All right, and the next one's a little bit off in relation to the other information that's been given to you, but you're going to see a problem of this later in your classwork tomorrow. And it's called unit analysis. Now you should be familiar with this if you've taken any of the sciences, the chemistry, the physics, even biology does this a little bit. Unit analysis is using units of measure in relation to 1. And that's the number 1. Hence the word unit. Unit represents the number 1. So a unit, for example, a unit measurement would be 60 minutes is 1 hour. That's a unit measurement. 100 pennies is $1. That's a unit measurement. Whenever you are using the units in terms of 1. So on one of your homework assignments tonight, you're going to be asked to convert from one unit to another unit. I'm going to give you an example where you're going to be given 66 feet per second is how fast something is traveling. But you want to convert it and change it to miles per hour. How many miles per hour is that? So what you need to be able to do is set up your unit analysis or your unit conversions, because you're going to start with 66 feet per 1 second. That's the given information. I need to be able to multiply it by something so that I can get rid of feet, so that I can get rid of seconds, and end up with miles per hour. So when I'm looking at this, that means miles needs to be on top, which means it goes with my feet conversion. And we should know this unit analysis here, that it is 1 mile to 5,280 feet. And then I have seconds are going to be to hours. And hopefully we know that there are 3,600 seconds in 1 hour. That's a unit analysis. That's a unit conversion. This allows me to change my labels, but keep everything in the same relationship. So do some multiplication straight across, 66, 1, 3,600. And then 1 times 5280 times 1, you're going to get a fraction over a fraction. And you always want to change that to a real number, meaning a decimal number. When we have real-world problems, and real-world problems are usually word problems, it has to make sense. You can't say that I went 24/7 mile per hour. That would not make sense. All right, you need to make sure that you convert it and that you change it into the proper 1.28 miles per hour, 67.9 miles per hour, whatever that number comes to, as long as it is real and it makes sense to the problem. Other than that, yes, we do leave everything as fractions, but if it is a real-world problem, we need to make sure that it makes sense. All right, tomorrow in class, you will have your first class assignment. It will be from the book, so make sure you have your book with you. And it'll be 1.1, and we will work on that in class and hopefully finish most of it in class so you don't have too much to do outside of lecture 1.2 tomorrow night. If you have any questions, make sure to talk to me tomorrow in class. Go back over these notes, pause them, rewind them, whatever you need to do so that you have all of the information.